Hey everybody, Miss Teacher here. We're taking a look at lesson 7.1, which is on exponents. Our essential question that we're answering, how do you write and find the value of expressions involving exponents? You can use an exponent and a base to show repeated multiplication of the same factor. An exponent is a number that tells how many times a number called the base is used as a repeated factor. So our example here, if we have 5 times 5 times 5, what's being repeated as a factor? It's 5, so that's going to be the base. And how many times is it repeated? It's repeated 3 times, so that becomes your exponent. All right, let's talk about how do you read it. So if you have an exponent of 2, we can read that as, this will be 5 with the little 2 there, can be read the second power of 5, or it could be read as 5 squared. And later on, we're going to learn why we use that shape, if you will, for squared. If you have a 5 with a little 3, that can be read the third power of 5, or you can read that as 5 cubed. All right, let's move on to unlock the problem. The table shows the number of bonuses a player can receive in each level of a video game. Use an exponent to write the number of bonuses a player can receive in level D. Use an exponent to write 3 times 3 times 3 times 3. So the number 3 is used as a repeated factor. 3 is used as a factor 4 times. So where do we get that 4? We count 1, 2, 3, 4. So if we're going to write that using exponents, we would write it as 3 to the 4th power. All right, so a player can receive 3 to the 4th power bonuses in level D. All right, let's look at another question. Try this. Use one or more exponents to write the expression. So we have 7 as a factor 1, 2, 3, 4, 5 times. The number 7 is used as a repeated factor, and it's 5 times that we see it. So we would write that as 7 to the 5th power. Over here, we have, careful because we have two different numbers here. We have the number 6 that repeats, and we have the number 8 that repeats. So we're looking at 6 and 8. Let's look at how many times they repeat as factors. So 6 is used as a factor 2 times, see 1, 2. And 8 is used as a factor 1, 2, 3 times. So if we're going to rewrite this using exponents, we would rewrite it as 6 squared times 8 cubed. Let's take a look at another example. Whenever you have 10 as your base and 3 as your exponent, we have a little trick that I'm going to show you. So if we think about 10 written out as its repeated factors, this 10 cubed, we would write 10 times 10 times 10. So that's being repeated 3 times. Now, did you know that if you had to write this out in standard form, that you would say to yourself, well, that's really 1 times 1 would be 1, and this 1 times this 1 would be 1. And we really have 1, 2, 3 zeros. 1, 2, 3 zeros. So it's not an accident that we have 3 zeros and we have an exponent of 3. That's a nice little trick that will help you whenever you have a base of 10. That works every time. Whatever the exponent is how many zeros you have when you write it out in standard form. All right, so let's take a look at how the textbook company wants you to think of it. So we would think of that 10 times 10 would be 100, and 100 times 10 would be 1,000. So just like as I pointed out earlier, if we have 10 to the 4th power, then we would throw another 0 in there, wouldn't we? All right, let's take a look at example B. We have 7 with an exponent of 1. So 7 is an exponent of 1. Wouldn't that just be 7? Write the factor 1 time, and that's only 7. All right, moving along. Write 81 with an exponent by using 3 as the base. So if we try 3 squared and we figure out what 3 times 3 is, we would get 9. If we try adding another 3 in with that, because we already know 3 times 3 is 9, so if we do add in another 3, so in other words, take this and multiply it by this extra 3, we would get 27. We got to keep going. So let's find what 3 times 3 times 3 times 3 is. In other words, 3 is a factor 1, 2, 3, 4 times. And we know that 9 times 9 would be 81, or really what are we doing? The pattern that we're following here is we're taking this last number and we're multiplying it by 3. If you do this times 3, you'll get the 81. So what does that mean? It means that we can write 81 as, or it's equivalent to 3 to the 4th power if we're going to use a base and an exponent to express that value. All right, moving along. Let's skip that for now. We may come back. So for the share and show, the directions here say write 2 to the 4th power by using repeated multiplication. Then find the value of 2 to the 4th power. So remember, this means that we have 2 as the base, and we have to have that written out 4 times. So we already have it twice. We need it 2 more times. And if we chunk this up, we know that 2 times 2 would be 4. And we know this times 2 would be 4. And if we find 4 times 4, that'll give us the standard form, which of course would be 16. All right, it's very important you pay attention to the directions because sometimes they just want the thing rewritten with exponents. Sometimes they want the standard form, or what does it equal? So let's read the directions carefully here and see what they want this time. Use one or more exponents to write the expression. So here we have the same number repeating as a factor. So that would end up being 7 to the 4th power. All right, so a good way to use this video is look at it, see if you come up with the answer on your own, pause it, and then hit the play button to see if you're right. So here we have 5 as a factor, 1, 2, 3, 4, 5 times. So the base is 5, but so is the exponent. For number 4, you should pause it and see if you get it right. But let's take a look. We have 3 as a factor twice, so we would write that part out as 3 squared times 4 as a factor twice, so that would be written as 4 squared. Now again, it doesn't say to write it out in standard form. A common mistake is to misread the directions and actually find out what it is when you simplify it. All right, when it does say find the value, then you do need to actually multiply the numbers together. So I like to always first think of it as what are the factors, write it out as the repeated multiplication. And if you don't have a calculator, then you would have to actually do the algorithm for that. So if we do 11 times 11, I don't know if you know the 11 trick. Did you know that anytime you multiply a 2-digit number by 11, so in this case, 11 is the other factor, did you know that you can just take these digits, space them apart? So we have a 1 and we have a 1. Did you know that if you add this and this, that's 2, and if you squeeze a 2 in there, that's the product? That'll work every time, 121. For number 6, they give us 9 cubed, so we first have to think of that as its repeated factors. 9 times 9 times 9, chunk them up. 9 times 9 would be 81. And then we have to find 81 times 9. Now, most people can't multiply that horizontally. You really need to do the algorithm off to the side. So if you do the 81 times 9 and do the standard algorithm for multiplication, then you'll get the answer for that, which is 729. All right, if we look at number 7, first we have to chunk it up as its repeated factors. So we have 4 times 4 times 4 times 4. Make sure you get them all in. It's there 4 times. And I like to just chunk things up with what I can do in my head. So we can do 16 times 16. And then again, we would have to do the standard algorithm for 16 times 16. Hopefully you don't need a review on how to multiply a 2-digit number with a 2-digit number. That should go back to your 4th grade year. But if you multiply those two things correctly, you would end up getting 256. That would be the value of 4 to the 4th power. All right, moving along. Write 64 with an exponent by using 4 as the base. So you would have to first, if we're going to write the number 4, right? But we need some exponent here, and we need to figure out what that is. So how do you do that? Well, let's try, if we do 4 times 4, that would be 16, right? So we know we got to multiply at least another 4 in there. So the question becomes, if we take 16, which is the product of these two numbers, and multiply that by 4, would that give us 64? So let's find out if it does. Here we get the 24. Here we get the 4 and the 2 more is 6. So that does match. So that means that we did have that third factor, which means that the answer would be 4 cubed, or 4 to the 3rd power. All right, so here it says use one or more exponents to write the expressions. So here we have the base would be 25, and then we have to count up how many times we see it. 1, 2, 3 times. Over here, We have the base of 1, 2, 3 of the factors of 2. So we have a base of 2. And since that occurs 3 times, we would put it as a 3. And then the other factor that we're multiplying in with that, so don't forget that multiplication sign, we have 4 as a factor twice. See, 1, 2. Down here, that's simple because we only have the one number that repeats. We have the number 8, but you have to ask yourself, how many times does that repeat? 1, 2, 3, 4, 5 times. All right, so if we find the value here, that's just write it out as repeated multiplication. Here we have to find what 20 times 20 is. So you can do that on your own. Find 82 as a factor once, you're just going to write the number 82. So we don't even need to do any math there. That's the same value. But this one requires a little bit of math. We have to multiply 3 times 3 times 3. So there's 3 factors. We need 2 more because it says 5. And you want to chunk them up. Chunk them up, maybe like this. That's a 9. This is a 9. And then you want to, don't forget about this 3 because we still have to multiply in the 3. And then we chunk them up. This would be 81. So we have to find what 81 times 3 is. 81 times 3, and if you do the algorithm correctly on that, 81 times 3 would end up giving you 243. All right, we'll do a few more. Let's make sure we understand how to do ones like number 16. It says complete the statement with the correct exponent. So again, they give you the base, and you have to figure out how many times do you have to multiply that out to be the given number. So you first try out squaring it. Now, if we square 5, we know that that equals 25. That's not big enough. So then you would say, all right, let's throw out another 5. And if we do 25, if we take this 25 and multiply that by 5, you would want to see if that equals 125. Do the standard algorithm to see if it does. Find 25 times 5. And if you do that, you're going to see you have a match. So then you would say to yourself, how many times do I have this as a factor? Count it out. And we would come up with 3 times, and therefore you would come up with the exponent of 3. All right, so you're going to try number 17 and 18 on your own, hopefully be successful with that. And then in class, maybe we'll go over the answers to that. Let's see if there's anything else. I think we're good. So for your homework, this is kind of what it looks like. So you have, find the value. That means you got to actually multiply out the repeated multiplication to find out what it equals. Make sure you're reading the directions carefully on your homework. All right, hopefully you found today's instruction not too painful. Exponents gets a little bit ugly when we start getting into algebra, but I think when we're just dealing with numeric values, it's pretty manageable.